you for watching this video of algorithms and data structure. Today we are going to verify how can we store our information or data in the machine, in the computer. We are going to use for that the random access machine. With this information we can do several operations like arithmetical operation, of course, like addition, subtraction, divide something, reminders, and also we can move the data with the loading, store, copy, and use control elements like conditional branch or return. With this kind of information we can move the data. In this case, I need first to explain you a little bit what kind of data we can use it. An example is solid or homogeneous, when the data is always the same kind of data. Or the not solid, the heterogeneous, where we are manage different type of data. We also have the static numeric information. In the static numeric information, the elements are constant, and in the case of the dynamic, the numbers can possible change. This is when we use the matrix. The matrix, what I'm referring, is something like this, where we can store the data in the static or in the dynamic dimension. In this case, we are going to use the matrix. That's really important to keep in mind. And also, we have the third classification, which is the cardinal continuous representation and the linked representation. We are going to check this cardinal continuous representation, and first I want to talk once again which is the vector. As you remember in the previous exercise, we state that the vector is some place that we can store data. And if we have our vector, that I call this in the computer, we will place some room spaces. These spaces we are going to call piece of memory. This piece of memory will have one size. Memory, it occupies one space that have one size, and we must to give to the vector one name. In this case, the computer will also starts by 0. In this, for academic purposes, I want to use the number 1. So B will be remain in this section the number 1. In this section, I can call like B and the number 2. In this section, I can call here the number 3. Once again, in informatics or any another computer language like C, Java, Python, we start with the number 0, with the 0 position. In this case, just to explain and give you some sense, I am going to use the number 1. So this vector is going increasing the numbers. With that, we can place some formulas to create this cardinal representation. We can using this vector some actuators like B3 is corresponding to this formula, to the memory size plus 2 elements that it's going to be multiplied by the size memory. With this formula, we can name it our vector in general functions like I. With this I, we can state that the memory is going to increasing with I minus, is I minus 1 multiplying by the size memory. This is going a good point of view that we can place. Let's make some exercise to keep it clear. And let's make some operations. Imagine that we have some information to place in our vector. I will start with this set of A that we have some several numbers such as 1, 2, 3, 6, and 3. And in our B set, we will have 1, 2, 3, 4. 1, 2, 3, 4. What are numbers? 5, 6, 7, 8. 5, 6, 7, and 8. These separate by 1 comma. With this information, we can do some arithmetical operations like or AND. If we make some simple operation like A union B, is going to be the same like A or B, or one addition. In that case, our set of these two sets, A plus B, A union or A or B, we will put together all the numbers that we can have here. So we will have 1, 1, 1, because we are making one addition of these two sets. We have also the number 2, which appear 2 times. The number 3 is 1, 2, 3. And the number 4, 1 time. And 5, I'm going to put here. 5, just 1 time. 6, 4 times. 6. And 7, and the number 8. And this is the end of these simple arithmetical operations. Also, we have the A and B. This is going to be just placed 1 time, which is in A and is in B. So, appears 1 here? Yes. Appears 1 here? Yes. So, which is appear in the A and B? The number 1. In the case of the number 2, appears here and here, so we will have the number 2, and we can check with the number 3. The number 6 also appears here, and nothing else. So this is the final answer: 1, 2, 3, and 6. If I'm correct. Let's make another operations to keep in mind. Let's suppose that we have a matrix operations of characteristical functions. So we will have this kind of matrix. Inside we will place some kind of vectors, apply the things that we saw. So we have in our A vector and the B, and also we will place some operations like is A union B, A and and B, and A minus B. In this place, we can set some intimate information like 2120, 212 is 0, 0, 2, 0. And in this place, ones. 1, 1, 1, 1. 1, 2, and let's place another one. Okay, what could be the addition of here, of these integers? So the result here, R union B, is going to be one addition. So we can play the number 3. And this is just another addition. This is going 2, this is 3, this is 1, 1, this is 4, and this is 1. What could be the next operation here? In this vector, it's what numbers appears like in the last exercise. So the number 2 and the number 1, the 1 appears in this case just one time. Okay? In this case appears also one time. This is have the same situation. This is not appear nothing here, or in A and B. This is have the same situation. In this is going to be the number 2. Let me explain you why. Because for reach the both numbers, you have the 1 here and the 1 here. That means you have 1. But also the number 2. The number 2 is here and the number 2 is here. That means you have like another number. That means 1 and 2 times. So it's 1 time. Here is not repeating the information, so it's 0. And here y is not 2 and is 1, because the 1 appears here and appears here. So the 2 appears here, but 2 is not appears here. That's why it's 0. So this is just only one time that it appears here, so you have the result number 1. And what about the subtraction? It's just one diminution of the numbers. 2 minus 1 is 1, 1 minus 1 is 0, 2 minus 1 is 1, this is 0, 0, 2 minus 2 is also 0, and this is 0. So this is kind of operations that we can make in one matrix vector. I hope this could be helpful for you.